Who doesn't like a good BMW with all the lights on? Let's get this thing started and all of the lights stay on. How interesting is that? Okay, so as we see on the dash there, we got ABS light, a park light, a traction control light, check engine light, airbag light, uh, you name it. It's got the lights. I got a pre-scan here, and pretty much half the modules are showing codes, and quickly with the topology that the top down has, it clearly shows us that the ABS module is not talking. So you can see right here, ABS, anti-lock braking system. They also call this a DSC. Not sure what DSC means, but I'm sure somebody knows. And if we look at, say, the engine control module here, we've got Valvetronic servo position sensor code, and then we've got this no message steering angle received from the DSC module. And then I'm sure these other codes are probably about the same. Rough road, no wheel speed signal, that's going to be from the ABS module. No message, operation of tempomat, cruise control. Well, if you ain't got wheel speed sensors, you're not going to have cruise control. So yeah, electronic park brake, DSC interface invalid signal. This wake up line code, that is history. That was me. I did that yesterday whenever I went to look at this vehicle. I was doing some testing and decided this thing needed to come to the shop because there's a lot going on with this thing. So CAS module, rough road, there's that wake up line again, that's me. Brake lights implausible, not real sure about that one. That one's a history code, but it is the same code as that wake up line. I don't understand that. A0, B0, oh no, BD and B0. Okay, never mind then. So I'm not really sure about that, but still, road speed signal, no wheel speed signals. So that's going to be the first thing that we approach on this, is the ABS not talking. So let's get the AllData pulled up, get some wiring diagrams, and see what this ABS module needs to talk. Alright, got the AllData pulled up here, and we're going to look at the wiring diagrams for this ABS module. So diagrams, and I'm going to be looking at the OE because I like OE diagrams. What can I say? Right here, DSC. We did have a couple of codes for saying something about an ICM, so we might be looking at this also, but let's start with this DSC. And here we've got some fuses feeding power, our grounds, DSC sensor. So our power feeds are coming from a junction box. Looks like we've got two, a 30 amp, a 40 amp, and a 5 amp. And you pay attention to the terminal numbers here. So that's the 30G, this is a 30 and a 30. So 30s are all constant. 30G, I'd have to look to see what that is. Let's see, let's duplicate this tab and we can do that real fast. Let's see what 30G means. We should find a signal names. There we go. So 30G can be deactivated in the event of a fault. So 30G is going to be a power feed that the junction box can turn off if there's an issue with it. And then we got a 15 wake up. 15 is basically like an ignition kind of thing, and wake up meaning that's what the module is going to be using to wake up. We got two CAN lines here, F CAN, high and low, and then we got PT CAN, high and low, and that's pretty much it. We do need to know what engine we've got. It is a N55, so this says N55 right here, so N55, not real sure what that means, because I would think it should be under a breakout like this. Maybe this connector or something. Not real sure. We'll dig into that in a little bit if we need to. So we've got two CAN buses that go to this, PT CAN and F CAN. I'm going to assume PT is powertrain and this F CAN is probably chassis. This doesn't tell me what those are. Can we do a F CAN? CAN bus connectors. Yeah, not really. I'm going to assume that's probably chassis, like a chassis CAN bus. So we can look up this splice numbers and see if we can figure out where else this goes if we need to. But let's get into this module and just start checking some powers and grounds to it. I've got the ignition turned on. We've got the T90,000 hooked up. It's on supply mode, doing 13.9 volts. And as you can see, with just key on, this thing pulls about 27 amps. And yeah, that's why you need a good maintainer. And I've got the ABS module here unplugged, got the voltmeter set up, and I went ahead and popped the cover off for the back of here so we could see the wire colors easier and know for sure we're testing the right circuits. We're going to start off checking these main power feeds here, or grounds here, and I'm going to do that with just doing a 5 amp load off of a, I think this is a H13 bulb or something like that. So it's a dual filament high-low beam, so if I need to, we could jump it up to about 10 amps and make sure we've got even better current flow. But let's just see if everything's here that we need. So I'm in one of the brown ground wires, that is pin 16, and these are power feeds, so that gets pretty bright, and as you can see we still hold 13.5 volts there. If we go to their other feed, 13.5 volts, and like I said, if we need to add a little extra current we could. That drops down to 13.1, so nothing wrong with that. That's pretty good. I'm completely fine with that. So that's one ground wire. So let's check our other ground wire here, and same thing, 13.5 volts. So there's our two main powers, or two grounds. All that's good to go. So let me swap my light bulb, and we will check the wake up. And I think there was one other power feed, of 5 amp fuse. Yeah, we've got another low current feed, so on a 5 amp circuit, that is battery power. It is this red, looks like a white stripe, but the diagram shows it being green. It could be green, it's hard to tell. But these BMW connectors are actually really good because they tell you pin numbers in several places. Let me see if I can get you in here to show you this. There we go, there we go. So 15, 16, you can see that says 46 and 47 there. So 45 would be that white one, or that red one right here. That looks white, but it could just be a faded color. Not real sure. But either way, that's pin 45 right there. So that's what we need to check. So we're just going to still use one of these ground terminals since we know that they're good. And so on the back here, it also gives you terminal numbers. So that tells me that right there is 46, that's 47, 16, 15. So we need 45. And you can see we got good voltage off that 5 amp fused circuit. So now we just need to test our wake up, and it is on pin 14. So if we've got 15 and 14 right here, nothing. Now that's a wake up circuit. So we have nothing. Let's take our bulb out here. And now we got 13.4. So this is something you need to be careful about when you're testing wake-up circuits. A lot of times wake-up circuits are not high current. Sometimes a very little bit of current is allowed. And this is how I had those history fault codes set for a wake-up circuit. Testing them with a light bulb. Can you test them with a light bulb? Yes, and we're going to show you that. So it depends on what bulb you're using. That was a 2 amp filament. Don't know if you guys can see that, 2 amp, where I have it wrote on here. If I go to my 1/2 amp, you can see my voltage still goes away. So let's change to a different bulb, or different test light. So this is the Lyle, I don't remember what the model number is. This bulb and this one pulls roughly about 150 milliamps. So let's pin that in here. And same thing, our voltage gets pulled all the way to 0. So what do y'all guys think? Is my wake-up circuit good or bad? Leave it down there in the comments right now what you think. Now we will get to my favorite test light, the J, let's see, can you guys even see this? Probably not. There we go. The J-35616-210. This is a special tool from GM. You can find this on the Special Tools website. This is, hands down, my favorite test light bulb for a reason. It is module safe, computer safe. It takes roughly 50 milliamps to light this bulb at 12 volts. This thing is voltage dependent on how much current it takes. So at 12 volts is about 50 milliamps. So let's see what happens with it. Look at that. Bulb is on. We have 13 volts still. So there we go. This circuit is good. It's just a very low current circuit to basically protect itself, protect modules. So, like I say, this is my favorite test light for a reason. It's good for 5-volt circuits, wake-up signals, things like that, testing low reference grounds and modules. This is safe to use. So, now we've got good wake up, got good powers, we got good grounds. Now what do we need to check? We need to check data. We need to verify we've got good data getting here, and pretty much the easiest thing to use is going to be a scope. If you don't have a scope, you can pick up the ATS or AES Wave U scope. It's pretty cheap, single channel. It's good for testing can lines. It's fast enough to read them. And then Ivan has a 2-channel scope that he uses on his channel a lot. I'll see if he can send me the link to that, and I'll post it down in the description. He loves that thing. It'll work for this also. All you need to do is see the CAN bus, see a good square wave, make sure it's not messed up. So let's get the Pico set up and see what these CAN lines look like. I got the scope set up here, and I am just using one of our known good grounds to reference my scope to. A lot of people are diehard, you gotta go to the battery, you gotta go to the battery for grounds. To me, it's like this module is using these 2 grounds to reference these CAN lines. So if there's something wrong with the CAN lines, I will still see it using these grounds. These grounds are sufficient. We've tested them. We know they're fine. So got channel 1, and we're going to start off with checking the FCAN lines. These white with a yellow stripe and white with a blue stripe. I don't remember the pin numbers right off the top of my head, but I think, yep, there's our CAN high wire, and just straight across from it in the connector should be our CAN low. So there you go. On the Pico scope over here, you can see we've got a really nice CAN bus waveform. Let's back up a couple screens. There we go. So there you go. Good square pattern. That's a very good CAN bus signal. So now let's move over to our PT CAN, which is just a few pins down. So there's our CAN high and our CAN low. And look at that. Well, that's interesting. We've got a CAN bus line issue. That's pretty weird. That'll definitely cause a no comm issue. So now we need to go a little further. What do you guys think that signal is? What do you think is going on here? If we stop this and back up a couple pages, where are we at? There we go. We can see we have some kind of signal, but it's very low and is pulling up. So that's a pretty strange signal. Let's see. Let's plug the module back up. I'm going to try to back probe these or pierce probe them, something. Let's see if the module itself is trying to talk. I know it's going to be hard for y'all to see, but I've got these just pierce probed down here, and then got my ground pierce probed also. It's not plugged up yet. The plug is undone here, but you can see on our Pico scope we've got that pattern. So now let's see if we can get this thing plugged up. Let's see what happens to our waveform. Look at that, that definitely changed. That has definitely changed. What do you guys think about that? Let's see. I feel like this is a broke wire. Okay. So as you can see in this capture right here, let me set you guys down here. So you can see right here in this capture, both are showing high, but here we see something a little different. And to me, that almost looks like, this is a good example, but when both of them are high like this, that looks like the signal going through a resistor and coming back. So this ABS module might very well have a terminating resistor in it. And we can maybe get in there with some probes and get an ohm meter on it and see if that's the case. To me, that's what this looks like. This looks like high side CAN flowing through a terminating resistor coming back on low speed CAN line. Hope that makes sense. If not, I've got another video, I think it was a Cobalt, I think, where I drew all this out and kind of explained it in detail. I'll put a link up here for you to go watch that, so we can go over, you can follow along with me. So still the same thing. This looks like an open circuit in the low speed line, or CAN low line, not low speed, CAN low. And let's see, right there, that looks like the ABS module talking. This is the ABS module talking. I'm almost certain this right here is the ABS module talking. It's because we got CAN high and CAN low. And the reason why the middle here is all kind of wonky looking, the bias voltage getting off, is quite possibly due to the circuit not having enough resistance in it, like the other end of the terminating resistor is bad or broken, something like that. Most modules can still read this and are completely fine with it because they're sampling at the higher and lower end of that voltage range to see what that message actually is. And then they're also doing a comparison. So if we do a math channel here, is it A plus B? Yeah, or A minus B. You can see that, let's move this down, that looks like a very good CAN message because that is what the module would be seeing. So if we go over here to this other page, right here, where we've got a broke wire, all these other modules are talking and the ABS module can't actually see it. This is what the ABS module is seeing. But going back, not trigger, turn that off. Let's go back over here to where our ABS module is talking. See, that module is talking. So now think, if all the other modules is fine, they can talk, it's because this is what they're seeing between each other. Their signal might look like this up here on that end of the network, but when you run the math channel, it's perfectly fine to them. They can communicate. So this looks like a broke wire on that network. So let me get a better diagram to show you this PT CAN network and try to find where it goes. And I guarantee you, we're going to find a break somewhere in this CAN low line, somewhere between this ABS module and everything else. So I was able to count the pins and get some leads in there for you. What do you guys think? Is there a resistor in there? Yep, there is. There you go. So I'm not so sure this is a dead module. I think we've got a broke wire, and we're going to find it. The OE diagram here shows these two wires. First stop they make is this X6031 connector, and AllData is pretty good. If you can search the connector number for BMWs and usually find it pretty fast, and it is basically just under the cowl, under the air filter for the AC system right here. So basically the harness is kind of coming up through here, and then it just dips down and connects here, and then up and out through the engine bay. So, like I said, harness goes down and around and plugs in the bottom down there. Let me get a light so you can see. So down there, you can see the red and blue twisted pair right here. Goes up into this connector, and it actually changes colors. It's going to be probably one of these yellow and blue wires that we need to follow along. So where does that go? Not really sure. I need to get a diagram that shows me further than that pulled up here. So I think the better option is to just use the aftermarket redraws, because like I said, they're a little easier to follow in some cases, especially with CAN bus lines. So let's find our DSC or ABS module. Here it is, DCS. And they change to yellow and black. Clear. Go away. There we go. All right, so they changed to black and yellow, according to this. So these are our two wires, and they kind of make their first stop here at this splice, and back to X6031. That's interesting. Let's take the highlights off here so we can see a little better. So they go through X6031, and it looks like they tie into the transmission control module and then back up to 6031. We could talk to our transmission control module. So that means on this side of the splice, these wires are fine. Let's see, and here we've got transfer box. I don't know if this thing was all-wheel drive or not, so I don't know if we could talk to that. But on the pre-scan, we only had one module we couldn't talk to, and that's the ABS. So my guess is between this splice point here and back, this yellow wire is broken somewhere. So let's do a little experiment. We'll see if we can get this connector out, find this red wire here and this red wire here. Should be easy. This pins 5 and 6 and 7 and 8, and we're gonna jump from pin 6 to pin 7 and then see if we can talk to this module. So down here I got the connector figured out. Pin 1 is on this side. So you got 1, 2, 3, 4, 5, 6 yellow wire, 7, 8 yellow wire. So I've got one terminal back probed in here. I'm going to back probe the other one. But first, on the Pico, you can see how we've got the time base set out here at 5 milliseconds. So you can see this section where our math channel shows we've got a good data packet for a module, and then we've got these other little spots where you can see there should be something, but up here we've got our CAN high and CAN low matching, so we don't actually have a data packet. And on the scan tool here, let me start the screen recording for that. If we go ABS module, you can see that it's going to come up and tell us we've got no communication. All right, so we hit OK. So I'm going to just back probe my other lead in here. Get my light so I can see what I'm doing. Okay, and here we go. Instantly that picoscope capture changes. And let's see if we can talk to our ABS module now. And we can. There we go. So we've got communication now to our ABS module. Verifying and proving we've got a broke wire. And since the diagram shows that connector basically looping out to the transmission and back, that gives us a pretty good head start in the area that we need to be looking for this broke wire. All right, so looking back on our wiring diagram here, we know we've got this issue with our PT can low, and we're suspecting it to be here at this splice, okay? And we know this goes on over to the transmission control module, and then these branches go over to a transfer box control module. I got this thing on the lift over here. It is all-wheel drive, and so we do have this module, but we had no codes for that module or anything like that. It does say it's in left rear cargo area, which is kind of strange, but either way, we're suspecting an issue right here. And the aftermarket diagram doesn't tell us where this splice is, but I went back over to the factory diagram for the ABS module, and so you can see here's our PT can low. So we're going up onto this, and we've got all these options, and we see N55 is right here. And at first it didn't make sense to me, but now that I look at it better, it makes sense. N52 and N55 both are here, so you got N62, 63, and S63 all should be following this path right here. So if we look back over here at our factory diagram, we have N55. Is that right? Let me make sure. Yep, N55. And we see our splices are actually numbered here. So X8091 and X8090, but we're concerned about 91. So just did the search bar function, had this link here that brought me to this picture, which tells me X8091 and X8090 and X8092 and 93 are all here. And I'm assuming in the bend of the wire. I don't know why they would put it right there, but it should be close to that. And then this is the harness that I see going down to a gearbox thing here. I'm guessing the all-wheel drive, like front, rear kind of thing. But it is saying that right in here is where our splice should be. So had to get the cover off from under here. It is a little oily. I mean, what BMW doesn't leak oil? One that doesn't run. And we see the harness running through here and down to our plug. And if you look, there is a little holder on the harness there that is not clipped to the transmission. Same with up here. So something has had this harness out before for some reason. So I'm gonna get it loose right here and see if I can get this harness down here to where I can get into it. Well, I got it down and got this little retainer off of there. And what do we see? Can you guys see it? Let me try to get the light up here where you can see. A little hard spot to get in and film, but come on, focus. Do you see it? I see it. The edge of this was pushed into this harness and cut the wire. Come on, focus. There we go. There's our problem. So now I just need to get this to where I can solder that wire back together, and hopefully our ABS problem is no more. Just wanted to show you real quick, got that wire soldered back together. If this will focus, got it soldered, heat shrinked back together, and those splices are in here. They're in the actual bend here. You can see them there. Pretty crazy. So now we know, and keep an eye out for that getting cut. Well, I got this thing, took it for a test drive, and the ABS doesn't have any problems, except it did set a code. I did a full health report again, or full vehicle scan again, and we did get a couple codes in the FRM, and of course we know this ECM is the Valvetronic position sensor, and then this seat fault, I tried doing the normalization where it basically moves the seat all the way forward and all the way back. It fails for some reason. It doesn't like the seat movement. No big deal though. The FRM set some brake light faults, so apparently we've got some blown light bulbs back there I need to look at. And the ABS set a code, but it's not going to set a light. It is steering column switch center malfunction. So these buttons do not work, none of them. So like they should be working, some of this on the infotainment screen over here, and they do not do anything, nothing. Why would that matter? Well, because we got paddle shifts here. So the paddle shifts are apparently in with the same circuit as these, and they don't work. So that is where that code come from. And yeah, that is it on the ABS. Customer is probably going to be extravagant that this got fixed before he sends it to the sale. So now he's only got the check engine light to deal with, and I'll call to see if he wants to address that or not. And if so, we'll make a video on troubleshooting it. And I don't know that I'll have time to fix it. If there is something wrong, like if the sensor is messed up, it'd be too far away before I could get to that to fix it. But anyways, thanks for watching everybody, and we'll see you guys later.